Okay, welcome back. What we're going to be doing now is making some of those same types of graphs that you guys learned how to make in Excel, this time in R. Now, I know you worked a little bit with R last week, and you may have had good experiences, bad experiences. Maybe some of that was influenced by your familiarity with statistics. Maybe some of it was just starting to get comfortable with kind of a coding-based environment. This week, we're going to kind of continue that theme. Again, no one expects anyone here to master R or master coding in any way, shape, or form. This is really just to start kind of helping you get a little more familiar with what types of data analyses, data visualizations, methods that are out there. And so this is really meant to be an exploration and just to kind of broaden your horizons a little bit. So at the end of the day, what I don't want is anyone to get overly stressed about this. If you're getting really stressed about it, just take a deep breath, step back, and remember that this is a very, very, very small part of this class. You could effectively not really understand any of this and you'll be perfectly fine. That said, I think it's an important skill and I hope that you still try to put the effort into trying to understand and learn it. Okay, with that said, here we are again at that kind of RStudio web-based terminal that I put together for you guys. Again, here to refresh you is the R terminal. This is where the code will be executed. And here's a little snapshot of what folders are available to you right now in the terminal. And then up here, we'll see some of our variables pop up. Now, as I did last time, first thing you should always do is you should make a new file that's an R script. This is kind of a living document that you can kind of execute your code from rather than typing it out down here. That way you can kind of refine things as you go. And so what we want to do this week is we want to make a box plot, we want to make a scatter plot, and we want to make a pie chart, just like we did in Excel. And so let's start with what we did, the same data sets we've kind of been playing around with. So let's start with the cars data set. And so we'll make a new variable called empty cars. And just like we did last week, we'll use the little arrow to redirect this function read.csv and tell read.csv where our actual cars data set is. It's going to be week 3 / empty cars data.csv. And if you look here in week 3, you should actually see it right here. So we're actually just telling R to look in that folder for that file and read it in. And so to execute it, we'll either hit Command Return, or if you're on Windows, I believe it's Control R. And here you're going to see that empty cars was read in. We don't see any red text or anything popping up any errors. So we can double check and make sure that it read it properly by looking at the first 5 lines with that same function we used last time, which is head. So we get head empty cars and execute that. And here we can see our data set down at the bottom. So first thing we want to do, let's go ahead and see if we can make a bar plot of cylinders versus miles per gallon. So again, like we talked about previously, if we've got a categorical variable as the independent variable and a dependent continuous variable, then a bar plot is typically a good way to represent those data. And so R has a built-in function called barplot. And if we bar plot and just look at the cylinders right now, empty cars, and we want to look at cylinders, recall here we're pulling up the variable, and then we're using, just like last time, that $sign to say, hey, we want to look at just one of the columns. And so as I type this in, it's going to predict what column I'm trying to type. If we just pull up the $sign, you can see all the possible columns here. You could even just click on it if you want. And so let's execute this and see what we get. Whoa, this looks kind of weird. So what we're looking at here is just all of the rows. So here you can see all the rows, and every single row is going to be represented as its own bar plot, which doesn't make a whole lot of sense. So here we can see that there was a 4-cylinder, then a 4-cylinder, then a 4-cylinder, and here you can see those 4 cylinders here, and then it jumps to 3 6-cylinders in a row. This really isn't all that informative for what we want to do. What we really wanted to do is look at a bar plot of miles per gallon versus cylinders. And so if we do MT cars miles per gallon, and we use that little tilde or squiggly line separating the two variables that we want to compare, and now execute it, what happens? Well, R does not like to make bar plots using these kind of formulas. And so using the default R bar plot is actually kind of a pain. And so what I'm going to recommend is that we don't try and use the basic R bar plot function. If you just wanted to look at your data really quickly and easy, you could actually just do the same exact thing with a box plot. Not quite the same, but here this is kind of along the lines of what we wanted to look at. Again, you've got your cylinders as categorical variables, miles per gallon on the y-axis. We haven't added labels or anything yet, but you can kind of see the difference in the data sets across these different categorical variables. But let's say we really have our heart set on doing a bar plot. What we're going to end up using is a library or a package within R. So one of the things that makes R so flexible is that anyone can write a bunch of specialized functions and put them together in packages. You can think about them as modifications to the default R environment. They add new functions, new features, and they're almost always, actually I think they're always free. And so a very popular one is called ggplot. It's a really kind of flexible way of making different graphs. And so I've already have a ggplot enabled on the server that you're using. And so to kind of turn it on, all you're going to have to do is type library, if I can spell, ggplot2. Notice it kind of knows that ggplot's one of the ones that we have. And so if we execute this, some things are going to happen down here, and it went ahead and loaded ggplot. So now we have access to the function ggplot. So ggplot can be a little bit scary at first, and just like R, I don't expect anyone here to master it. I've put together a little bit of a cheat sheet to kind of help you along the way, and as I do this, I'm going to kind of show you how to use this kind of cheat sheet. And so I've given you all access to what I'm calling this cheat sheet.r. Basically, I've kind of got a little workflow with some examples of code for how to kind of do what I'm showing you to do right now. We've already done this. We did read CSV and found that MT cars data set, and we saved it as MT cars. Here I'm just using data as a placeholder. Same with the location. We've already headed the data just to make sure that our data looked right, and then we loaded ggplot2. So the first thing we're going to need to do is ggplot2 is kind of this kind of builds upon itself. You kind of keep adding on different lines, and each line of code will add a different feature to the graph. But pretty much all graphs start with the exact same starting point. And so here is this kind of ggplot function where it's going to always expect you to tell it what data set you're looking at. And then this AES stands for aesthetics. So aesthetically, what's going to be the variable for your x-axis? What's going to be the variable for your y-axis? And then this optional fill, which will make sense here in a minute. So the way I like to use these kind of cheat sheets is use them as a template. There's nothing to stop you from just copying this text and pasting it in here, and then going through here and kind of tweaking everything a little bit. So our data is actually called MT cars. We want to compare on our x-axis. Again, remember, x-axis is going to be your independent variable. We want to look at cylinder, right? And on our y-axis, we want to look at miles per gallon. And then we want to perhaps color the bars. We could color the bars by what cylinder they are. Maybe the 4-cylinder is going to be blue, 6-cylinder will be red. It'll make it just a little prettier to look at. So if we execute this, our expectation would be that we're going to get a plot. Now here's where ggplot is both kind of flexible but also sometimes frustrating. All right, so we told it everything we wanted. And we get a graph here that shows x-axis is miles per gallon, y-axis is cylinder. Why aren't we actually getting what we want? Well, ggplot can do anything from bar graphs to pie charts to scatter plots. So we have to tell it what kind of chart we want. And so while this is the default first line that you're always going to make for ggplot for the most part, you want to kind of add a plus at the end of every line and add more information about what you want it to do. So if we go back to our cheat sheet, here are some lines that can determine the type of graph. So here's a line that will tell it, hey, I want to make a bar graph. So we can just add this line here. And I'll talk a little more about it here in a second. So this less function stat summary, you don't have to know what that means, but the geometry of this is going to be a bar instead of maybe a scatter, something like that. And we want y, the y-axis, to represent the mean of each of those categories, which is typically what we want our bar graphs to show. And so no, rather than just executing each line individually, this plus connects them. And so now we can just go ahead and execute both at once. And here you can see now we've got a bar graph. We've got cylinder, we've got miles per gallon, and it's starting to be kind of what we want it to look like. Okay, so what's something that's actually missing from this box plot, or this bar graph, that we typically would like to represent on here? Well, something we typically like to have are error bars, right? We talked a lot about standard deviation last time. And so if we want to put error bars on here, all we have to do, go back to our cheat sheet and let's figure out another piece of information that we can add on here. So lines to add error bars using standard deviation as the error bar is this stat summary, geometry is an error bar, and then we've got some other information there that I'll talk about. So what we want to do is we want to add another plus sign because we want to add another line, so just addition. And here, now we've got the geometry is going to be error bars. We're saying that the function here of the data, and that's not important for you to remember, is that we want it to be the standard deviation. This is R's word or ggplot's word for standard deviation. And here we can play with the width of the error bars, the color of the error bars, whatever you want. So let's go ahead and execute this now. It's going to take a second to think about it. But here you can actually see now we've got our error bars. And let's play with it. Let's say, hey, maybe we want really wide error bars. Let's make them 0.5. And maybe let's make them seafoam. Let's see if we can make them seafoam color. Oops. Let's see if we can make them red. And so if you really wanted red error bars, you could have red error bars. I think probably black and 0.2 was more than sufficient. So we'll go ahead and execute that. And so here you go. We've got a nice little graph. It's an error bar. It's got most of the stuff that we want on it. We're still missing a few things. You know, SIL isn't really that informative. And so we could go and start to add some labels as well. And so let's go back to our cheat sheet. And so we've got different ways of adding labels right here. You could add each label as a separate line. So you could go plus X label, plus Y label, plus title. Or you could just do it all kind of in one big line as well. I don't mind kind of making these things big, but sometimes you might just want to be efficient. So let's go ahead and add one more plus here. And now we're going to add all of our label information. Cylinders, miles per gallon for the y-axis, the fill, which is basically over here. We could even add a GG title, which was also listed here as something separate. If we want an actual title at the top, we could say miles per gallon versus cylinders. And so let's go ahead and execute this whole thing now. And now we've got pretty much our completed graph. You can do whatever you want to tweak this. There's other ways to change the default colors. It's really up to you. But now hopefully that kind of gives you enough information on how to go from reading your data in, figuring out what two variables you want to use, and then slowly but surely, one step at a time, building kind of a nice customized graph using the different addition lines within ggplot. Okay, let's go ahead and do the same thing now, but we're going to make a scatter plot. And so for a scatter plot, we're going to use a different data set. We're going to use an iris data set. And so if we go back to files, within week 4, we've got this iris.csv that I put in there. And so we're going to say iris read.csv, and it's going to be within week 4/iris.csv. We'll execute it. We'll go ahead and double check that everything looked good. And here we can see the data set. Again, this is a continuous data set with sepal length, petal width, and sepal width. And so we can kind of make a number of different continuous by continuous comparisons, which are all really good types of data to make scatter plots with. And so let's look at what making a scatter plot would look like using basic R. So to make a scatter plot in R without using ggplot, you just use the function plot, and we would say sepal dot length, which is one of the variable names here, versus, again using that a tilde or squiggle line, sepal dot width. Notice these things are case sensitive, and so be careful how often you use capital letters. Sometimes in your data sets it can kind of be a pain to deal with. And then we're going to hit comma, and we're going to tell it what kind of data we want, what the data it's going to be pulling from, which is the iris data set. So if we execute this, here we can see a scatter plot of sepal width versus sepal length, kind of what you would expect. Now, let's use what we learned in ggplot for the bar plots and make this a little nicer. We can do a lot more relatively easily. So going back to our cheat sheet, let's go back with what we start. How we started this whole thing. We use this kind of starting ggplot line. So we're going to start with ggplot. Now our data is going to be iris, and our x-axis is going to be sepal length. Our y-axis is going to be sepal width. And here we're not using bars, so we're not going to worry about fill. So we're just going to get rid of this optional piece right here. We're going to close that. Now, if I hit execute, are we going to see a scatter plot yet? No, and that's because, again, we haven't given it a line equivalent to what we did for the bar graph, telling it that, hey, we want to make bars that represent the mean. So instead, we need to start adding a line that tells us that we want to make a scatter plot. So if we go down here to lines that will determine the type of graph, here's scatter plot. Rather than geometry equaling a bar plot, it's going to be a point plot. So scatter plots are just a series of points. And so we can go ahead and add plus here, and we'll paste that line in. And so let's look at what we got. We've got geometry equals point. Now aesthetically, we can set the color by a variable name. So this is kind of similar to fill in the bar plot. And we can also set the shapes of our points based on a variable name. Now if we look at our data set, we have a nice categorical variable called species. So we could actually color all of our points by the species name that they have. We could also set so that the shapes are different by the species name. So let's go ahead and look at this. And so now, what was kind of a blob of a bunch of different points now is actually kind of informative. We can see that this species Setosa in red, the ratio of its sepal width to length is actually quite different than the other two blue and green species. And if you're colorblind, they're all different shapes as well. So this is kind of a nice way to look at those data. All right, let's continue on and kind of repeat what we did before and clean up this graph, give it some of the important pieces we need. We need labels and a title. So this time we'll just do all individual labels. We're going to go plus, plus, and plus. And so now what we've done, and I kind of like to put little spaces here so you can see that these are all parts of this ggplot. You don't actually have to indent at all if you don't want to, but it's kind of nice for looking at. So now we're saying, hey, let's make an informative X label, let's make an informative Y label, and let's give it an informative title. Let's execute this. And now you've pretty much got a graph ready for publication. You might want to play with the background or the colors or do some more things with it, but you went from one data set and made a plot. Now what's powerful about this is in Excel you would have to start from scratch if you decided you wanted to compare something else. What if I wanted to compare sepal length versus petal length? It would be really as easy as going through and typing petal there and rerunning this. Now look at how informative this is. This petal length versus sepal length really separates these different species. Now you'd have to go through and change your labels and make it again, relative to what you're actually comparing. But this is the nice thing about ours. You can just kind of replace things and remake graphs, or you could copy and paste this whole thing and very quickly make 4 different graphs for all the different comparisons and make them have appropriate labels, and then you could go ahead and save them all, and you'd be done with your graphing. You wouldn't have to start from scratch with every Excel graph that you were making. Okay, last one, but not least, is the pie chart. So we're going to go back to the empty cars data set and just see if we can make a pie chart that shows the proportion of cars that are 4-cylinder versus 6-cylinder versus 8-cylinder. And so the function for this is not going to be in ggplot. It's just going to be pi. And so if we do a pi for empty cars and we want to look at cylinder, we can tell it what color we want it to be and all these other things. But let's see what happens if we just do a default empty cars, the cylinder column. Well, that is not at all what we expected, right? This is showing every single car and not actually giving us information on what cylinders are what. And so the pi actually does not, kind of requires your data to be formatted in a special way. Now we can cheat and tell it that we want it to format our data set as a table, which is what the pie chart wants. And I apologize, this seems kind of tedious, but sometimes this is the nature of these things. So all we're going to do is replace empty cars cylinder with table and parentheses around it as well. And so if we execute this, now that it's thinking about empty cars as a table rather than a data frame, which is something I don't really want to get into right now, you can see that now we can see the proportion of 4 versus 8 and 4 versus 6 or 6 versus 8 cylinder cars within our data set. Now we can kind of clean this up and kind of make some other nice changes to it. We could tell it that we want the colors to be gray colors, and we could execute this thing. Oops, sorry. We could tell it that we want 3 different gray colors, and we could execute it. So now it's black and white. We could also tell it that we want the title to be number of cylinders, and we could execute it. Now it's got a title on it. You could also tell it specific colors. You could give it a list of colors that you wanted. Maybe we want sea green. Maybe we want sea green 1. And maybe our third color would be sea green 3. And if we execute this, now we've got this kind of beautiful sea green color. So that's just kind of basic how to make a pie chart in R. It's a lot less to it than kind of the ggplot, also a lot less flexible. So hopefully this was informative. Again, my recommendation is to always kind of have a cheat sheet of little snippets of code that you can kind of repurpose for all these different steps. That's how most of us do this in the real world. Is I don't remember, oh, okay, if I want to make a scatterplot, I need to use stat summary, then geom point, then aesthetic, and the color of the species. I go back and look at little examples of code that I've saved or that you might find on different websites. And so I really recommend that you kind of treat it as building a recipe rather than trying to memorize how to do something. And so with that, you'll be kind of practicing this yourself on your own. And again, I want to stress not to get stressed out about this. This is just kind of your first step in a direction of playing around with this type of analysis and visualization. And everyone's going to learn at a different pace, and that's totally okay.